What is an LEP flashlight? The name of the LEP flashlight is mainly to distinguish it from traditional LED light source flashlights, which refers to flashlights that use white laser light source illumination technology. There are also flashlights on the market that use both LED and LEP light sources, such as the Beams Terminator M1 flashlight. LED is the abbreviation of light emitting diode. Its fundamental principle is that visible light is emitted when electrons recombine with holes. The light emitted by LED is spontaneous emission, and the photons emitted by them are different in emission direction, polarization state, and initial phase, which results in a large difference in light intensity of such light sources at different spatial angles. For example, when we are outdoors, sometimes we may view large light screens from the side and notice that the images on the screen are distorted. This is because the distribution of LED chips on the screen is narrow, which results in insufficient clarity at wide viewing angles. The solution is to increase the density of the LED chips on the screen to improve the light intensity at wide angles. However, this typically leads to an increase in screen cost and energy consumption. The core of the LEP light source is the laser diode. Laser is the light-stimulated emission of atoms. Its theoretical basis is that a photon can cause a stimulated atom to emit a photon of the same nature. Laser photons have highly consistent optical properties and extremely good directionality. How to make an LEP flashlight? Firstly, lasers emit monochromatic light. So we need to convert monochromatic laser light into white light, which is a mixture of different colors. Blue laser shines on yellow fluorescent crystals, which then emit high brightness white light. LEP is the acronym for laser excited phosphor. When choosing and manufacturing fluorescent materials, we mainly need to consider two aspects. One is the efficiency of fluorescent materials in capturing photons, and the other is the efficiency of fluorescent materials in thermal energy transfer. Now let's integrate this structure into one module. The module is divided into two types according to the different internal structures. The first type is reflective structure. The advantage of a reflective structure is that if the exit glass is accidentally broken, the laser beam will not directly emit outside the metal casing, thus avoiding accidental injury. The second type is transmissive structure. The advantage of transmissive structure is that the module is small in size and highly adaptable. When we pair different types of lenses with the laser module, we can achieve functions such as ultra-long range shooting and focusing. The larger the diameter of the lens, the stronger the focusing ability and the longer the shooting distance. Taking an 11W transmissive light source as an example, when paired with a 27mm lens, the module's emission angle is 3.6 degrees, and the shooting distance can reach 1300 meters. When paired with a 55mm lens, the module's emission angle is 1.6 degrees, and the shooting distance can reach 2,900 meters. This is a selection of high-profile laser flashlights. Will LEP flashlight replace LED flashlight? Firstly, the answer is no. In remote lighting, small angle, and high brightness lighting applications, LEP has advantages that LED light sources cannot surpass, so LEP technology will revolutionize the lighting market in these areas. However, LEP light sources have obvious disadvantages in wide-angle lighting. The focusing function is not suitable for LEP flashlights. Here are several LEP flashlights with greatly reduced luminance values after focusing. Here is an explanation of a common misconception. Luminous efficacy is the ratio of luminous flux to electrical power, usually measured in lumen per watt. Luminous efficacy can reflect the energy-saving performance of LED, which is an important indicator for measuring the performance of modern LED light sources. However, this parameter is not applicable in the field of lasers. Engineers familiar with LED flashlights may find it difficult to imagine an 11W laser light source with a luminous flux of less than 1000 lumens, illuminating up to 2,900 meters. To achieve a 2,900 meter illumination distance, LED light sources typically require luminous flux of over 20,000 lumens, along with a large diameter lens. The important reference parameter for measuring LEP light sources should be luminous intensity. Luminous intensity refers to the luminous flux within a given solid angle in a specific direction from the light source. Luminous flux, in simple terms, is the amount of light perceived by the human eye. For the same amount of light, the difference in the apparent perception by the human eye can be significant due to variations in emission angles. For example, with a luminous flux of 500 lumens, both an LEP light source and an LED light source, when equipped with a commonly used 27mm lens in flashlights, will produce different effects. The LEP light source will emit a thin, highly intense beam of light projecting into the distance, while the LED light source will cast a low-intensity wide-area light spot nearby. This also explains why LEP light sources are not suitable for focusing. The luminous flux of low-power LEP light sources used in flashlight is often difficult to exceed 1,000 lumens. When focused, the beam angle increases, and it becomes apparent that the light is insufficient. Currently, commonly available LEP flashlights on the market only use a single LEP light source with low lumen values. In contrast, LED flashlights of similar prices utilize multiple high-lumen LED chips. Therefore, increasing the number of LEP chips can raise the total lumen output of the product. However, due to cost and size considerations, the multi-chip LEP solution is currently only applicable to searchlights and aircraft lighting projects.